Hello everyone. In the last class, we have discussed about what is called mixture and its types. Now today, in this class, we are going to discuss about what is called solution, its components and its properties. So let us begin first of all with what is solution. So the word solution is somewhat related with mixtures. In fact, if we say it is related with a type of mixture, we have learned about what is called homogeneous mixture, heterogeneous mixture. So it is one of a kind of a mixture. So let us see. A solution is a homogeneous mixture of two or more substances. So we can say that it is a kind of a mixture, but it is homogeneous in nature. Next, a solution is also sometimes called a true solution. So if the name comes true solution, then it is nothing but it is a solution. And as you know, solution is a homogeneous mixture of two or more substances. For example, lemonade, soda water, air, alloys, etc. Now lemonade we all know, soda water also we all know, air also we know, it is a mixture. Now what are alloys? Alloys are also mixtures of two or more metals, or we can say it is a mixture of a metal and a non-metal that cannot be separated into their components by physical methods. Some examples of alloys we can have is brass, which is a mixture of 30% zinc and 70% copper. Clear? Now solutions are not only liquids that contain either a solid, liquid or gas dissolved in it, but we can also have solid solutions, that is alloys, which I said just now, and gaseous solutions, that is air. So it is not necessary that a solution will always consist of a solid or a liquid. Means it will be a mixture of a solid or liquid or gas or solid or gas. No, it can be solid and solid also. That is, for example, alloys, which I said just now. And it can be a mixture of gas and gas also, just like air. Air is a composition, or you can say a mixture of gases, various gases. Clear? Now in a solution there is homogeneity at the particle level. Now what does this mean? Okay, let us see. Let us take an example of lemonade, which we know that it is a solution. Now if I say, after preparing the lemonade, if I say you to taste it, will it taste different at different interval of time? The answer is no. It will taste the same right from the beginning till the end. If you drink it, it will taste the same throughout. Why it happens? Because there is a homogeneity. Homogeneity in the sense, while preparing the lemonade or while preparing that mixture or the solution, it has dissolved completely with one another. The components of that solution has mixed in such a way that it is maintaining an uniformity, a homogeneity throughout that solution. There is no difference at a particular interval or at a particular point where the solution tastes different, or where you can say that the solution is showing some different characteristics. No, the solution throughout the whole solution, it will show the same characteristic properties as it has shown at the other level. So we can say that there is a homogeneity, there is a uniformity at the particle level. The particles of the solution, or you can say the components of the solutions, are mixed in such a way that you cannot distinguish them or separate them part by part. You cannot separate them. It is completely mixed. Clear? Now let us see the next one, components of a solution. Now what are the components of a solution? Now there are mainly two components of a solution. Now what are they? So let us see what are those two components. Yes, the two components are solute and solvent. So when we mix a solute and a solvent together, it forms a solution. As you can see in the figure, the solvent is a liquid here, solute is a solid here. So if you mix it, it will form a solution. And as you can see here in this figure of the solution, you can see these are tiny particles of the solute and the solvent, and they have been mixed in such a way that it is maintaining a homogeneity throughout the solution. There is a uniformity. It is not that we can easily see that solute is here or the solvent is here, it is separated in some way or the other. No, there is a total mixture, or you can say there is a total homogeneity throughout the solution. Clear? Now let us see the next slide. Now let us discuss what is actually solvent and solute. So what is solvent? Solvent is also called the dissolving phase. Now the component usually present in larger amount of the solution that dissolves the other component in it is called the solvent. Whichever. Now it is not necessary that the solvent has to be a liquid. It can be a gas also. It can be a solid also, as we have just seen in the previous slides, that the solution can be a mixture of solids and solids also. Yes, it can be a mixture of gas and gas also. It can be a mixture of solid and gas, solid and liquid, liquid and gas. So it can be anything, whatever. So the main point is that whichever component of the solution is in larger amount, that is the solvent. Say in our earlier case, say for example, if we make a salt and sugar solution, salt and water solution, then definitely their water will be the solvent because it is in larger quantity, and the salt or the sugar what we have taken, that will be the solute. So we'll see that later on, some examples we'll see. So I hope this is clear to you. What is solvent? The component of the solution in which the other component is dissolved, and since it is other components are dissolved in this component, that is the solvent, so solvent has to be in larger amount, then only then we can dissolve it. Clear? Next, solute, the dissolved phase. It is also called the dissolved phase. That is a component which is usually present in lesser amount of the solution that dissolved in the solvent is called the solute, which gets dissolved in the other component, that is the solute. So let us see some examples, it will be more clear to you. So some common examples of solutions we can see. A solution of sugar in water is a solid in liquid solution. Yes, this is a solid and liquid kind of solution. In this solution, sugar is the solute and water is the solvent. That's what I said a while ago, that when you mix sugar in water and make a solution of it, then that sugar will be the solute and water will be the solvent, because water is in larger quantity than the sugar. Now next example we can see aerated drinks like soda water. Now what is aerated drinks? The drinks, those contain some kind of gas in it. Say for example the cold drinks that we take, or the soda water. Here soda water has been taken. Now in soda water what is present, do you know? In soda water most of the thing is carbon dioxide, and this carbon dioxide is mixed with water, nothing else. It is a carbonated water, you can say. That's why it is written carbonated water. So that means there some kind of gas, that is carbon dioxide gas, is added to it, as a result of which when we drink it, there is a what kind of thing, you can say, a reaction occurs, and as a result some gas tries to evolve from our stomach. So here also we are not going in that details. So what I mean to say is that here carbon dioxide is the solute and the water is the solvent. So here you can see that it is a gas and liquid mixture, or you can say a gas in liquid solution. I hope this is clear. Now let's move on to the next one. Properties. Now this is important. What are the properties of a solution? Now any mixture which shows these properties, then we can consider them as solutions. So let us see what are the properties. First one, a solution is a homogeneous mixture. Yes, it has to be a homogeneous mixture. It cannot be a heterogeneous mixture. It has to be a homogeneous mixture. Or we can conclude also from here that all the homogeneous mixtures are solutions. This might be asked in the exam that all the homogeneous mixtures are the solutions or not? Yes, they are solutions. It has to be a homogeneous mixture. It is must. Next one. So as you can see here, here I have taken, if you can see it properly, sodium chloride. We know it's a carbon salt. So sodium chloride is composed of what? Sodium and chlorine. So we have broken it down in the atomic level. So sodium atoms and chloride atoms, they join together to form the what is called sodium chloride. And this sodium chloride, when we mix with water, then it gets dissolved with the water molecules, maintaining a homogeneity or uniformity throughout the solution. So that's why we can say that the salt solution is a homogeneous mixture, or we can say it is a true solution. Clear? Now next one. The particles of a solution are smaller than 1 nanometer in diameter, so they cannot be seen through our naked eyes. Yes, obviously we cannot see. Once salt, obviously we can see, but once it gets mixed with water, can we see them? No, because the size of the particles is very, very small, nearly 1 nanometer. 1 nanometer is equal to 10 to the power minus 9 meter. So it is microscopic level. Even if it is 1 millimeter, that is also very difficult to see. Just imagine it is 1 nanometer, which is 10 to the power minus 9. That means it is at the microscopic level. Clear? Now, because of very small size, they do not scatter a beam of light passing through the solution. So the path of the light is not visible in a solution. Okay, this you can try at home. Make a true solution, for example, salt or sugar, whatever, an easy one, and then pass a beam of light with the help of a torch light. I can show you the figure here. Yes, in this way. Taking a torch light, you try to pass a beam of light through that solution. You can take it in a glass beaker, or if you don't have a beaker, you can take a glass itself so that the light can pass through it, since glass is transparent, and try to see the path of the light. The path of the light will not be visible as they do not scatter the light. Clear? So this you can try at home for yourself and see what exactly happens. So this is kind of an activity you can try at home. Next one. The solute particles cannot be separated from the mixture by the process of filtration. The solid particles do not settle down when left undisturbed. That is, as solution is stable. Yes, of course. When we mix any solution, if we leave it that way, undisturbed, even for a longer period of time, you will not see any sedimentation occurring at the bottom of that beaker or whatever container, because it has totally mixed. As I said, that there is a homogeneity. So since there is a homogeneity or uniformity throughout the solution, it doesn't get settled down. If it would have got settled down, then it would have been a heterogeneous mixture. But as we all know, that it is solution is a homogeneous mixture. So that thing won't happen in case of what is called a solution. Clear? Now, it cannot be separated with the method of filtration. You can try that out. You make a true solution and then you pour that solution with the help of a filter paper. You cannot separate its components. Then how can you separate? Yes, there are other methods through which you can separate, like the distillation process, or you can do it with the help of what is called the chromatography method, or through evaporation method. How we can separate the salt water and the what is called salt and the water, we can separate through evaporation method. In that way only we separate and get our salt, the common salt, from the seawater. So there are different processes, but yes, we cannot separate it through filtration because that's not possible. We cannot separate its components. Clear? So I hope you all have understood today's class. So that's all about solutions. There are further more topics on solutions which we'll discuss in our next video. So till then, you can study what is a solution in your book and whatever has been taught in this video. So that's it then for today. Thank you and have a nice day.